Now, this is a continuation of our odd and even functions. We're going to talk about functions that are not odd and not even. So these are the neither functions. Just like with the other two, we looked at the exponents first. So let's look at the exponents for this particular function. All right. We have an exponent of 2 and an exponent of 1. That's that, disappearing exponent. Okay? So those are definitely not even and not odd. So let's look at problem number 2. I have an exponent of 3, I have an exponent of 1, and no exponent. So let's look at this. I have an exponent 3, an exponent 1, and I have an exponent 0. Okay, guys, 0 is neither odd nor even. So with that said, I have 2 odds and 1 not. I wonder if that makes a difference. So let's look at this third one. Okay, I have an exponent of 3 and an exponent of 2 and an exponent of 1. Again, I have some odd and I have an even. So this one is definitely, just by looking at the exponents, I have neither odd nor even exponents only. So this is definitely under the neither category. Now let's look at our table of values. Let's look at our table of values. All right, remember now, with the evens and the odds, opposite values gave us something very specific. So let's look at opposite values here. And opposite values of x, well, I don't have opposite values there. In fact, I have negative 2 and 0, and there's no way those are related. Opposite values, no, not opposite values, nothing. Negative 2 and negative 6. Opposite values of x, no, I don't have anything very fancy happening there. Let's look at this one. Opposite values of x, okay, no. I don't get opposite values of y. I don't see anything else. See opposite values of x, no. Well, look at that. I got a 6 and a 6. Maybe I have a pattern here. But does it have to happen all the time? Opposite values of 3, no. Well, I don't get a pattern happening again. Okay. So let's look at this third one. Remember, now, opposite values of x, definitely don't get opposite values. Opposite values of x, no. Opposite values of x, no. Okay. So I definitely do not have a pattern forming in my table of values. So let's look at our graphs. Again, I went to Desmos and I looked at it. This one here looks very similar to an even function, as in I have this lovely curve and I definitely have a line of symmetry. But my line of symmetry right here is not the y-axis. In order to be an even function, it has to be the y-axis. To be an odd function, I would have to have rotational symmetry. So let's look at this one that was close to being odd. And I have a picture here. Definitely doesn't have a line of symmetry running through it. It doesn't have rotational symmetry, which means if I flip it back and forth, rotationally, I should see the exact same graph. And I don't. So I don't have rotational symmetry, and I don't have exactly a line of symmetry that's the y-axis. So this does not fall into even or odd category. Let's look at this third one. Interesting. This looks an awful lot like an odd function. Let's see if it works like an odd function, that when I rotate it, I get exactly the same picture no matter what. So let's flip it back. Well, no, it sort of jumps there. It is definitely not odd, though it's close. It is close. It is, and I guess it would be close because I do have 2 odd exponents. But this even exponent really sort of throws me off. It sort of looks like my line of flipping, or my rotation, should be here and not there. And remember, rotational symmetry means I'm rotating about the origin to be an odd function. And that's it. These are all neithers, and talk to you later. Bye.